In this lesson, I'm going to demonstrate how to create a simple Python program. But before we in fact dive into the actual Python programming language, a few concepts along the way are always helpful. First, let's talk about what are commands and functions in a programming language. So all programs are partially constructed with various functions. Basically, a function is nothing but a set of instructions performed by the computer when instructed. And you might have heard this term function over and over again. If you dive into any programming language, a function is nothing but simply a set of instructions. For example, the print function. So let me demonstrate this. For example, let me go to my Python shell here in the idle, and I'm going to say something like print and just say hello world. And Python would do as instructed as soon as I use the print function. And here the word print is a function and hello world is our parameter. So what Python does, it color codes the function called print in purple and then a parameter in green. And of course, you can create your own color scheme by going to options within the shell. But by default, this is how Python color codes it. And the output is color coded in blue. So once again, the word print is a function and hello world is our parameter. And typically, you would just call that function by typing the word print. Okay, next is Python data types. What I've done here is I've compiled some of the important ones. There are others as well, but Python has many native data types. And here are some of the important ones. For instance, we can use the Boolean operator such as true or false, and we've seen this in our previous lessons as well. The next is numbers, and numbers can either be integers such as 1, 2, 3, 4, and so on, or floats such as 1.1, 1.2, fractions, 1 divided by 2, 2 divided by 3, and so on, or even complex numbers. So the important things to note here is that numbers in Python can either be integers, floats, fractions, or even complex numbers. Strings are sequences of Unicode characters, so for example, such as an HTML document. Bytes and byte arrays is another Python data type. An example would be a JPEG image file or a PNG image file. Lists are simply ordered sequences of values. So for instance, you could create a list in Python that contains colors, orange, purple, yellow, and so forth. So you're building a list. Tuples are ordered immutable sequences of values. These are very similar to lists, but they are permanent, right? So you cannot really change them until you convert them back into a list. And dictionaries are unordered bags of key value pairs. So not to worry about some of these data types at this point. I'm going to have other lessons that are going to explain each one of these, and we'll of course program using Python each one of these data types. But for now, just giving you an idea of what Python data types are important so that if they come across, you would know what they mean. And most times when you're creating a program, you'd use any one of these data types. Very important, Python is case sensitive. So all names in Python are case sensitive. So variable names, function names, class names, module names, exception names. If you can get it, sell it, call it, construct it, import it, or raise it, it's case sensitive. Okay, so just keep that in mind when you're working in Python. And let me in fact demonstrate this one more time. For example, if I were to say something like print using the capital P as opposed to the lowercase p, and notice automatically it does not color code. So Python does not color code the capital P because it doesn't really know. But in any case, let me demonstrate. So I'm going to say print, and I'm going to say my name is John, spelled correctly, and then close my parentheses, Now my parameter is correct, so there's nothing wrong with that parameter because you can see the color code automatically. So this is one good way and a valuable way of using color coding, and Python does that for you. So while you're writing your code, you don't have to worry about whether I'm writing correctly or incorrectly. It automatically would not color code the function. So if I were to execute this, click enter, and notice I will get an error because Python does not recognize the name print is not defined. Whereas if I were to use the lowercase one more time quickly, and Python is going to print the output. So Python is case sensitive. Keep that in mind when we're programming in Python. Objects, another important area in Python. Everything in Python is an object, and everything can have attributes and methods. And we'll get to attributes and methods and classes later on, but right now just understand what are objects. So all functions, for instance, in Python have a built-in attribute such as _doc_, which returns the doc string defined in the function's source code. And the sys module is an object, for instance, as an example, which has an attribute called path. But here, just for now, everything in Python is an object, and everything can have attributes and methods. So this is the important element that you need to know about objects at this point. We'll get into detail. I'll have a separate lesson on objects. Few important things about objects. Different programming languages define object in different ways. For instance, in some programming languages, it means that all objects must have attributes and methods. In other programming languages, it implies that objects are subclassable. In Python, the definition is much broader. So in Python, some objects have neither attributes nor methods, but they could, on the other hand. And not all objects are subclassable. However, everything is an object in a sense that it can be assigned to a variable or passed as an argument to a function. Another important element when you're writing a code is indenting your code. Code blocks are defined by their indentation. And by code block, we simply mean functions, if statements, for loops, while loops, and so forth. So for example, let's open up a sample Python file by clicking on File, Open, and let's navigate to our Documents folder, Data Files, and Python folder. And here are several Python modules here. For example, I'm going to select one of them, like myInputFunction.py, open, and here's the code. So it depends on your own requirements how you indent. Python doesn't really specify the indentation rules per se, so you can create your own indentation. Typically, it's just blocks of code. So in this particular scenario, the variables are, for instance, name, age, and color, and the rest of the code is indented. And using blocks of code and indentation simply helps you as a developer or a programmer to go back and revisit your code and add lines. And that's very common in programming. So when you're writing a program, you'll always go back to one of the code blocks and add to it. It's not something like you would just write one program and that'd be the end of it. You would have to revisit your code and add because requirements change, or your logic within your program entails that you need to go back and change the code or add more lines to your existing code blocks. So I just wanted to quickly show you the concept of indentation. So let me close this. So code blocks imply functions, if statements, for loops, while loops, and so on. Indenting starts a block and unindenting ends it. And there are no explicit braces, brackets, or keywords. This means that white space is significant and must be consistent. So when you're writing code blocks, you need to be consistent. Another important element of writing your first program is we need to follow a simple logic, right? So whenever you write a program, it has to be logical. And a flowchart is the best way to not only understand logic but also document your program as well. All programs start with a logic. In other words, there's a start and there's an end. So in this particular example, it starts by asking a question, is it raining? And the diamond represents the decision box. And if it is raining, the next step would be to ask, do you have an umbrella? And if the answer is yes, only then you will be able to go outside and the program would end, which means the answer is true, therefore you'd end the program. However, if you do not have an umbrella, then in your code you would ask or write another line, such as wait a while, for instance, and then after a while check whether it's raining again or not. If it's raining, it will loop back to wait a while, because you have to wait until the rain stops. But if the rain stops and it's not raining, so if the answer is no, then you would go outside and the program would end. So very simple logic. So anytime you write a program or you think of creating a program, think of your program and follow logical steps in order. And each step would then contain your code block, right? So you would create a code for, is it raining? You would create a code for have an umbrella, wait a while, you do a loop here, a code for loop block, and then end the program. So just a basic simple logic that you would follow. And it's a good idea to first document or diagram your program itself that you're about to create before you actually start using Python shell and start creating your program. And since this is a beginner's course, it's always a good idea to use a flowchart.